Welcome everybody to our lecture about 100 analog missions with AATC. Let me share the screen, and I hope now everything is visible. Okay, what we have done, I think it is time to share with everybody interested in analog missions in the world, because I think that we already obtained some milestone. Even we didn't plan this, but it went quite fast because in 9 years we managed to organize 100 analog missions. We had visitors from many countries. Thank you all for coming to us, trusting us. We had the representatives of 48 nationalities here in Poland. And as you can see on the map of habitats and habitat locations, the map was prepared by world's biggest analog event. You can see that Poland is quite large and significant on this map. So how does everything started? I must say that everything started in 2016, even 2015, when I was working at Advanced Concepts team at the European Space Agency in ESTEC in Netherlands. I was working on the concept of subjective time perception during long-term analog missions. With my neuroscientific background, I thought that this will be quite interesting topic to develop, but I needed not only theoretical research, but I needed data from experimenting part. And in order to do experiments, of course, I couldn't simulate the orbital condition, yes, without gravity. But I could think of running experiments in chronobiological chamber. This is the word. So it is the chamber that you can make illusions with time, and that you can deprive people from the main circadian clock pacemakers. So light, some social events that can synchronize your biological rhythms. The easiest way was to create the own habitat, and I was talking with my teams because, of course, I was never alone with these ideas. And I asked them, can they help me to build the habitat in Poland? Why in Poland? Because here we had simply easier life, we had simpler procedures, and definitely cheaper possibilities. So the first base created in Poland was Modular Analog Research Station. It was created in the south of Poland, in Rzepiennik. But this habitat that you can see on the left side, this was only gaining know-how. We never made the proper analog simulation there. The first, so to say, a real analog simulation was made in north of Poland, where we moved the base to Piła, and we created Lunaris base. Probably some of you heard about this habitat. It is quite well recognized on the map of the world's analogs bases. And there we set the Space Garden Company together with our investor, Marcin Traple, and we started organization of international missions. This was very interesting to gain new knowledge about how to prepare procedures for the analog missions. Everything was quite easygoing. We had several volunteers to participate and to support us in development of this kind of research. Then, because of my private issues, I had a quite large family. It was hard for me, settled down in Kraków, which is south of Poland, to travel to Piła for each analog mission. So I decided to sacrifice my old house. It was a wooden 100-year-old house, and I transformed it into the simulator of orbital spaceships. Sometimes it could act as a lunar base or Martian base, depending on what kind of scenario we wanted to perform. Anyway, in this tiny place, we managed to organize most of our analog missions, and now we are developing into something larger. So we are mostly focused on now running simulations on small populations of people, not like on the spaceship, but rather like on the space base, where we have more than 6 to 8 people. So now we are number one in organizing these large analog missions. By large, I mean 30 people crew. And in the nearest future, I'm honored to create, of course, again, together with the team at the university, the first habitat that will be academic habitat. You can't believe how many problems are related to policy and to legislation of such infrastructure inside the academic buildings. But anyway, our vision is to accelerate the human spaceflight research globally. This is nothing related with promises, with some job offers. We are doing this as a hobby. So we are doing this basically after hours, yes? This is whole private investments. So if you think that we are gaining money out of it, if we have some profits out of it, we are not doing this for this. Absolutely not. This is our passion. This is our vision. And we want to bring astronaut trainings for everyone. Why? Now, there is some interest here simply because I have 4 kids and I want my kids to develop in a very nice environment. And in order to create this environment, we need to train everybody. We need to train our bodies, we need to train our lifestyles to be planetary friendly, I would say, yes? And when everybody will be planetary friendly, the life here on the Earth will be planetary friendly. And my kids will be happy. This is my goal. Okay, there is some privacy here. Then practical activities in extreme isolated environment. Well, again, we want to provide this for everybody simply because now it is very inaccessible. It is mostly done by space agencies. How to get there? Nearly impossible. So this is what we want really to do, to bring access of bioastronautics education at all levels. And we are doing this starting from the primary school level up till very, very professional level. We are very much interested on crew adaptations because our missions are short. They are mostly 1 week long, simply because our people, they need to pay for participation of analog mission. It is maybe not a lot. It is like a hotel with food, but still, they need to travel here to Poland. They need to make this effort. And why we want them to pay, at least for their food and accommodation, simply because then these people have completely different motivation. If they pay too much, they expect a lot from us, and we cannot provide them a high life 5-star hotel. Yes, this is not about it. We are not a tourist company. So we want highly motivated crews because only with these people we can really build a fantastic bioastronautics community worldwide. And we also like to induce increased creativity in all people coming here to us and to induce problem solving. So for many years, we were focused on mission planning and preparation, how to prepare a proper documentation that our people will feel comfortably and not overloaded with some duties before their mission, because they are workers. Yes, they work. This mission, analog mission, was kind of a hobby. So they came here voluntary, paying their money. We didn't want to make them too much busy with reading documentation, with preparation to the mission. Yes, that's not the point. The point is training for us. And because of that, we were really trying to simplify paperology. Another thing that was interesting, I think, for our crews was to make our pre-trainings interesting. Of course, it is not always possible, but we try to show them before they meet one day before, strange people, they don't know each other usually. So we want to show them that their bodies are amazing, that the team itself, it's amazing, and they will do amazing mission. In order to do this, we use several sensors. We use several environments like a cryo chamber with minus 120 degrees of Celsius, where they are inserted, and we observe how they react to stress. And then, of course, they have a huge success. They manage to do this, and they are very happy. And already before the mission, they have some success. This is important. The habitat itself must be attractive. What it means? It is not about the walls, the Star Trek, Star Trek-like architecture. It's about how much information you can get out of your analog mission. And because of that, we implemented so many sensors. It is over 80 sensors in the tiny habitat that is monitoring environment and the human health during 7 days of the analog mission. Here you can see only examples of some graphs that the Mission Control Center can see and analyze later the data and publish them. Of course, we are interested in each mission data, but in order to get a power for statistical analysis, we need to have not one analog mission, not two, not 10, not 20, but much more. Everybody who is working with human research, we know how we differ, yes, how different bodies we have. And measuring one astronaut, 5 astronauts, this is completely not enough. Now in space, there were 600 people on the orbit. And I must tell you that this is still not enough to say anything according to the excellence of science. So we need more data. And I believe that analog missions are critical point to get a proper data. We just need to create the proper environment, the proper simulation, controlled environment, and then we can gain really a lot of data on many, many, many people. Okay, so what we can see here? We can see that some parameters are very strictly related with the crew presence in the habitat. For example, CO2 levels, humidity, temperature, this is all generated by our bodies, yes? So we need to consider these parameters regarding the crew selection, regarding the crew activity scheduling. Everything is very sensitive regarding these 3 parameters. Another parameter is light illuminance. So how the crew is working, what is the distribution of experimental part, the workload, yes, in the schedule, everything is affecting the main parameters of the habitat. Daily mission operations, usually we create very standardize mission operations with procedures. What is only changing in our analog missions, mostly these are experiments because we have different people, we have different crew, we have different specialization of the crew, yes? So, of course, we will not give an engineer to write a poem. Of course, sometimes we ask, but if the person doesn't want to do this, of course, why? This is not the prison, yes? We want to gain as much as possible out of the crew. The crew composition determines what kind of experiments are on the board. And then based on this, we are building the crew scheduling, extravehicular activities, if the mission is containing EVAs, and then health monitoring, habitat operations, everything is somehow adapted to this main core of the mission, so experiments. Evolution of the mission schedule. Here you can see the schedule that we used in the beginning when we started our analog missions in lunar space. And the schedule was kind of dynamic. So you could see the schedule was designed for every day for each analog astronaut. So you can see analog astronaut columns here. And on the left side, we could see the main tasks that crew should do. This was like a really important tasks on the left side, so crew will not forget. And on the right side, the Mission Control Center was adding some immediate protocols that please crew do this now. We have some extra task for you for this day. Please do it. Yes, so it was easily traced, easily followed by our crews, this kind of schedule. But as you can see, it was in a way overwhelming. So we decided to completely standardize the mission schedule and to simplify it. Very important thing was timing. So we completely changed the time reference from UTC time as it is used, for example, for ISS operations. We used the mission time that started from our 0 and ended roughly our 18, depending on the tasks and on the day of the mission. But in general, the skeleton of the mission was always the same. So we never repeated the schedule for every day. It was for all missions the same schedule. Yes, so everybody was really simplified in a way that everybody knew at which hour of the mission what the person should do. And for larger crews, like 30 people crews, we had the same schedule as here. So instead of commander, communication officer, astrobiologist, crew medical officer, and so on, we had all teams here. So the schedule was designed for whole team, and the skeleton was exactly the same, the structure. Yes, so it was quite easy. Additionally, for larger crews, we had the milestones. So for each day, we had tasks that must be done by everybody. And also we could develop some estimation of time needed to perform a specific experiment. Yes. For EVA procedures, we had several people. I wanted to thank here Pedro Pedroso, who came to us and who developed wonderful papers for EVA procedures. All nice protocols, all nice scheduling the extravehicular activities. So this was made by his team during the colony mission, and I wanted really to thank him and appreciate this hard work. Well, beside procedures for extravehicular activities itself, we had manuals for how to use the suit, but also to facilitate this training, we asked the main director of EVAs to familiarize with the documentation, and then he was teaching directly his crew, EVA crew, to take over all important instructions how to do this, not to destroy the suit. Yes, so everything was done by the team, and then when analog astronaut wanted to perform EVA, it was just the crew taking care of all procedures. So the person could nearly be not prepared for EVA, considering all technicalias, and only focused on the experiments that the person had to perform during EVA. The mission communication was facilitated. So in case of a small cruise, we use a signal channel and only written communication to skip all misunderstanding related with the accent, with all things like this. When we have larger crews, we are not having mission control center, but now we are planning to have it. So we still are thinking how to do this. If you have any ideas, recommendations, if you want to join us in some way, please contact us. Scientific operations, also, we try always to prepare protocols for each experiment. Beautifully written, step-by-step checklists, everything must be done so everybody can very easy trace the subsequent steps of the experiments that needs to be done with a high quality inside the habitat. System maintenance, troubleshooting, everything already we developed as a simple table, so our analog astronauts, they easily can fill in the tables and communicate what is happening. Well, the habitat that was hosting nearly 100 missions inside is getting over. I mean, we are finishing analog missions in this location because, as I mentioned, we already have a lot of data. Now we need to publish all this information because I think that we collect enough data to say something about how this environment that we created affected short-term adaptations on humans. And this is what we are now planning to do. So a lot of publishing, wrapping up all information that we gained and sharing this with all global community. So we are closing this place. We are closing this habitat at the end of this year. So I wanted just to mention the main achievements in this habitat. It is kind of nice to see and to show to everybody that even this kind of habitat, it is completely not what I wanted to do, yes, because of low budget, I only could create with my team this. But even in this kind of habitat, we could run professional research thanks to our collaborators, thanks to motivated crew. These people were really motivated and they still are. They are still developing space sector in the world. So what we managed to do, we managed to develop several prototypes of energy recovery using physical activity of the humans. Yes, we had a small gym, and in this small gym, we could convert energy from our muscles into some power. Yes, this is important. Then we created several mobile applications that are used by us, by our students, in developing cognitive functions of our brain. So reflex, memory numbers, spatial number, spatial memory, everything like this. And many people, they were actively contributing in developing this kind of train like an astronaut mobile application. So thank you for that. It was a great honor. Then expedition number 100, we wanted to make this 100 mission a very special mission, and we succeeded with organizing a mirror mission to Ignis on International Space Station, where Polish astronaut Sławosz Uznański-Wiśniewski, he was testing Mexen in LEO, a project that I was personally involved. So development of smart bands, monitoring devices of human health. And we managed to run with success this analog mission, simulation of how other people than astronauts can perform these same procedures as on ISS. This was very interesting study using exactly the same tools, exactly the same methods, and exactly the same procedures. This was really cool, and our crew is still developing, is still practicing to develop in space sector. What we managed to do already, we ran very complex mission in the habitat. I think this was one of the most complex mission. The project that we organized in our habitat was the set of bright missions. In total, our crews spent 1 month and a half in the habitat. Each mission took 2 weeks, and each crew performed 3 missions. One mission was a control 2 weeks mission, then another one was mission with visual light and infrared light, and then another 2 weeks was exposition to ultraviolet light together with the visual light. For this, we were collaborating with the QLab company from Silesian area, and they developed a very interesting sunlight simulator. We used their equipment and implemented in the habitat. The equipment was very interesting because we could modulate the intensity and the frequency of light in the habitat. This was great because we could really see the effect how light is important in isolation, especially in space. So we wanted to see how to use the light, how to decrease the energy supply to provide lighting in the habitat, what is the limit of different type of frequency of light in the habitat. Well, UV light, you know that it can be harmful, but on the other side, it produces serotonin, dopamine, vitamin D, urocanic acid, so many photosensitive molecules that are really critical to our health, that we need to consider UV light in the future in our enclosed bases. So this was quite interesting study. We are wrapping up all documentation. We have a lot of data, as I mentioned. So it takes some time to really publish it during organizing another missions and another projects. It's a hard time, of course, but you can see already here on the screen, we have a diagram on the right side down, how all these 14 days and these 6 2 weeks missions were different comparing to different lightning conditions. And in particular, I wanted to tell you that the mission with infrared radiation, so no UV light, it brought the lowest levels of CO2 in the habitat, which is very interesting. And we also detected cortisol, melatonin, serotonin, even testosterone in the blood, in the saliva and urine of our crews. So we have really interesting research going on that, and we want to share this with a very short future. Another very interesting study that we managed to do in our habitat was to induce very specific condition, and because it was very isolated habitat, we could increase levels of carbon dioxide during the analog missions, of course, to the safe levels, 2000 ppms. But because of that, we could manipulate with the ventilation system. We could build different types of ventilations, monitor how this system may affect the crew well-being and the habitat environment. So what you can see here, we compared 12 analog missions with a different number of crews. So we had 4 crew members, 5 crew members, 6 crew members, and depending on that, we were measuring how this difference is affecting environmental parameters inside the habitat. It is not only CO2, of course, I mentioned before humidity, I mentioned before temperature, light illumination. Of course, all these parameters are different comparing to different crew composition. We wanted to understand how, based on this data, enormous amount of data, how we can build the best model, the digital twin for analog missions in the future and for real lunar and Martian missions in the future, because I think this is a critical knowledge, critical information, how to build bioregenerative life support systems. Once understanding what is the rule, what is the principle, how interior architecture, ventilation system, how this affects the main parameters of atmosphere inside the hub. We observed, of course, activity levels. We observed the sleep quality in isolation, depending on CO2 levels. So these data, all we have, and here you can see the distribution of different parameters, the variety, how this change through one mission to another mission. Yes, this is very interesting study to compare what are the main correlations, the common parts, what are some disturbances and why they are caused, because this is super interesting. So here you can see the distribution of noise. Of course, it was the noise measurement during the day, not during the night. During the night, we always have 60 hertz. Then distribution of temperature, then distribution of humidity, and of course CO2. So these parameters are closely related to the crew composition, yes? So we believe that larger crews will bring more noise, yes? More CO2, more humidity, more temperature. That's the thing. But what is the proportion? What is the relation, yes? And how humidity is related to temperature, how humidity is related to noise, because when you talk, you spread some humid into the air. So it should be proportional, yes? Very interesting things. Then bioregenerative life support systems. Well, we are in the beginning of this journey, but we create more and more advanced prototypes. This is the first prototype that was created by Design of Kielce. It was a designing company on the left. It was implemented in lunar space. We started from very simple but very elegant setups. And now we are building more automated and more complex systems, more closed systems, and related from human parameters. So we try more and more with more advanced approach to reach higher and higher quality results. Together with Collegium Medicum, with Professor Magdalena Strus and her team, we are also very much interested in how human microbiomes affect other humans in isolation. There are several research on International Space Station related to this, but we still cannot read a lot about what is the principle, what is happening there. Still, we have not enough people to measure, yes? So with that, we are developing the big project of measuring many people in isolation. By many, I mean at least 30. At least 30. We measured them before the mission, during the mission, and after the mission. We measured the microbiome of the habitat before the mission and after the mission. And based on this, we try to establish guidelines of biosafety for space habitats. And this is very tricky and very expensive. So I'm very grateful to all professors involved in this huge research that we are doing here with AATC. Another collaboration, which I believe is very interesting for future exploration on the Moon and Mars, is the virtual reality support, especially for deprivation of sensory deprivation in isolation. You know, you are living in the same area all the time. So you need to have some inputs from outside, and the virtual world seems to be the solution for several aspects of this sensory deprivation. And we believe that inputting a proper way of thinking, good media, good positive energy will of course have an effect on the quality of performance and the atmosphere on board of the isolated mission. We try to detect and to develop a new non-invasive health monitoring systems. Based on this, we try different classical methods. Of course, first we need to understand the process. We read a lot of literature. We have a lot of students interested in developing completely new sensors. So now, recently, my student, Mateusz Koba, he developed a non-invasive vitamin D monitoring system for isolated missions and for general use. So definitely you should see his lecture. This will be, of course, on our conference, so he will share this data with you. And then As I mentioned, we had a lot of data from these standardized missions. So beside the experimental part, which is always diverse depending on the crew composition, we have always the same measurements and collection of data. What is collected? Well, water used, urine produced, wastes produced, wet wipes used, diet analysis, sport activity, sleep quality, and many, many, many other parameters that are, we believe, critical in future modeling of the digital twin for analog missions. Here is just an example, quite old one, but still, this is based on EMPOL missions organized together with Professor Bernard Foing and his collaborators, Euromoon Mars. So here you can see that depending on the crew, depending on the mission, we have a different use of water. And there are many reasons why it is like this. It is not only that some crews were super active in the gym. It is also about personal needs for water consumption. What we are focusing in the habitat during planning of the mission and being a designer of such activities, we want to induce creativity in our crews. So the habitat is not putting anything on the plate. So you cannot read everything in your manual. You need sometimes to be creative, to improvise. And this is something that we really appreciate, and we really want to induce from every day of the mission to the last day. For example, we want to ask our crews to design and test a composite biomaterial. Then we want them to prepare something that can be used in the isolated base and what can be used. So they are really thinking creatively and they are performing this. Here, our analog astronaut, Serena, maybe you know her from other habitats. She wanted to expand the space inside the confinement. So it is very interesting project that she was managing in our habitat. Then fertilization of regolith simulant samples. We wanted people to see the plants on something that is completely not good for plants. Yes, so we tried to observe how to make this inside the habitat fertile. And we ran several tests in simulated microgravity using random positioning machines. So there were cell cultures, seeds, even some worms, nematodes. In our habitat, we have an electronic stage where you can even build a CubeSat. And here, Justina, our fantastic collaborator, she was proving that she can build the CubeSat in the habitat, which was very cool. Many experiments were interactive, so they required the whole collaboration of the crew. And I think that these experiments were unforgettable for many people because they were not easy. They required super high focus and careful and being very careful. But at the end, they really were showing that collaboration between crewmates is very important. Here you also can see teaching on the missions, sharing experience, sharing culture. It was very, very nice. We even tried to build some interspecies relationships in the crew. So, for example, on one mission, we asked everybody to have a cockroach friend and try to observe how this relation is changing during the days. Then we try to build several filters for purifying the water, how to cope with the limited resources in such confined space. This was very interesting. Of course, time illusions. My favorite topic, subjective time perception, of course, is everywhere, always during each analog mission. Well, what are the results? In general, we see that we can modulate the time perception on many ways, not only using food, social aspects, but we have special tools and methods developed to make people feeling that the day never ends, something like this. It's very cool. For human factors and crew operations, we developed several tasks that are integrating the crews. We already gained a huge experience about monitoring of psychology of our crews, the well-being state. Only by cameras, we can already see, and by reports, by daily reports, we can already see what is happening in the habitat, who needs some special support. Emergency procedures, this is something quite significant to our AATC habitat. Many people, they love it, and they even are advising us, Agata, you should increase the number of emergency simulations because they are really cool. We feel like in the game, we feel that we are needed together to solve some problems. So this is very interesting. And of course, post-mission operations. We don't want to finish the whole adventure at the end of the mission, yes? After mission egress, we have a debriefing, and then we start wrapping up the data, publishing. We try to make our analog astronauts active. So we always say this is not the end, this is just the beginning. Considering the emergency simulations, we are not really writing games, yes. We are not providing fake data. These are real data that display on the screen in the habitat. And we give people some limited time to solve a special task. And if not, then these parameters go higher and higher. Some emergency simulations are synchronized to space weather. You can trace space weather using open access devices or internet. So we can easily see when there is an X flare. And when we have this kind of situation, we ask our crews to get into emergency mode because there might be some magnetic storm or whatever. And they are measuring the habitat and doing specific procedures to specific tasks. I told you about what happened in our small confined habitat that is coming to the end, the whole history. And now we are focusing on development of the huge habitat, which will be more than 500 square meters surface of isolation. We try to build the complete isolation, microbiological isolation, in order to make a really, really professional and unique research to contribute in the development of human spaceflight. This is the actual state of our habitat. It is still very raw, but already we organize here missions. We organize rocket workshops, stratospheric workshops, junior space camps. And I believe that this will be only better every year. So now our focus will be only concentrated on this habitat and habitat at AGH. This is the visualization, how we want to build the private capsules for 50 people. So 50 capsules will be created. We already bought infrastructure and materials. So we just need to have time in order to build it. We have several inspirations after organizing the world's biggest analog with 30 people on board. We are really wrapping up the data, and at the end of the year, we will publish the first very, very important paper about how we exchanged microbiomes. We had people from several continents, several countries here. So we obtained super interesting data that we want to share with others. We are visible because of our collaborators, especially I wanted to thank here Professor Carolina Orozco-Donais for showing us that what we do is kind of interesting and it may be inspiring for others. We are running a lot of education, and every year we are having more and more people engaged in this educational process. So we are really happy that we can truly contribute into development of bioastronautics, a new cadre for human spaceflight research. And maybe I will not go into the details. I invite you to be with us at this AnalogAstro conference. This is the first such conference. I believe that in the next 10 years, we will have another big milestone and another moment to meet and to see what has happened, what is the history, and what we can learn out of it. So I invite you to our conference sessions where our analog astronauts will speak about their personal achievements, their space careers, about published papers. I wanted to show you what we already did and what is already the return of investment of all of us. Because it is not that only AATC is contributing into this, but everybody who is visiting AATC is contributing into development of bioastronautics globally. So I wanted to really thank all of you for all this hard work. And with that, I wanted to thank you for attention and welcome to collaborate.